Here we're going to look at now the metamorphic rock samples. So we know that metamorphic rocks are rocks that have been transformed. So these rocks were once some other rock. So a limestone can turn into a marble. So marble will be the metamorphic rock and limestone would be the protolith or the parent rock. So here we have sample numbers 60, 61, 62, 63, 64 and 65. So let's start with sample number 60. This is sample number 60. If you look closely, it has a very crystalline texture. It's very hard. It cannot be scratched. Very hard rock and has a crystalline texture, no layering. So we would say this is a non-foliated metamorphic rock. So metamorphic rocks have two important textures, foliated and non-foliated. So this one is definitely non-foliated. So it's a non-foliated medium crystalline rock. And this is sample number 60. But let's test it with acid just to make sure it's not marble. Well, it is not marble, so this is another rock. So you'll have to look in your chart to find out what rock this is. So now that is sample number 60. Now here you can see another rock here. This is sample number 61. Sample number 61 is also coarse crystalline and it can come in many colors, so it can even have the same color as sample number 60. And sample number 60 can have the same color as sample number 61. So they both can have the same color, and they both have the same texture, which is a non-foliated texture. But what differentiates them from one another is that sample number 61 will react with acid. And you can see here the vigorous reaction. See the bubbles. Now that shows us that this is composed of calcite. This rock is composed of calcite. Now sample number 60 did not react with acid because it's not composed of calcite. It's composed of mostly quartz. So you will look in your chart and find out the name of sample number 60 and use the properties to do that. So the properties are the crystalline texture, the non-foliated texture, and the fact that it does not react with acid. Now you can use the properties of sample number 61 to identify this one, and it is a rock that is crystalline, non-foliated and reacts with acid. Now let's look at the samples 62, 63, 64 and 65. What they all have in common is that they are all foliated metamorphic rocks, which means that they have been compressed, they've been subjected to pressure, and they're composed of minerals that have yielded to the pressure and oriented themselves perpendicular to the pressure and thus created a metamorphic layering in the rock. Now these rocks 62 to 65 have different grain sizes. 62 and 63 are fine grained and foliated. 64 and 65 are coarse grained and foliated. So let's look at the first one, 62. So this is sample number 62. It's very flat, you can see. It forms these flat layers, very tight. It looks a lot like the sedimentary rock shale. However, it is the metamorphosed shale. So this rock is much harder than shale. You can see it's much harder than shale. It has a sort of ringing sound when you hit it with the nail. A shale would have a more of a thud because it's composed of clay minerals. This is composed of minerals like mica and quartz, but they are very fine grained, producing this very tight rock. Now this rock has a cleavage because it tends to break along these plates, and so that's one of its diagnostic properties. So that is sample number 62. Now sample number 63, we have two samples here. This is the first one, and in cross section here you can see that it has a wavy surface, and that's one of its features. Now at higher temperatures than this sample number 62, the same parent material, so if it started out as a shale, at higher temperatures it will turn into this rock, which is sample number 63. And here is another example of 63 where you can see the shine on the surface. See, there's a silky sort of sheen, and also you can see the wavy layers. So when you see this wavy foliation, we know that it is sample number 63. So it has a name, and you will find out what the name is when you look at your chart. So these are the two fine-grained foliated metamorphic rocks. Then we look at sample number 64. Now sample number 64 is, see, you can see it's shiny because the minerals are now coarse enough to be visible, and the most predominant mineral in this rock is mica, and that's what is shining away, muscovite mica. You may also have some biotite mica, and it's evenly distributed everywhere. You can see on the side that it's very layered, so see the foliation here very clearly, and you can see the abundant mica. This texture has a name, and you will find out what that name is when you look at your chart, and you will also discover the name of this rock when you look at the chart. This rock is abundant in our Manhattan in Central Park. When you go on your field trip to Central Park, you will see a lot of this rock exposed over there. Now this rock here is a very high grade metamorphic rock because the higher the grade, the larger the crystals are. So this has been subjected to very high temperatures and pressures that only occur deeper in the ground, deep in the ground. So in the roots of mountain ranges and places where you have very high pressure and temperature, you have these kind of high grade metamorphic rocks that will form. So that was sample number 64. And our last sample is sample number 65. And this rock here is the highest grade metamorphic rock that we have here. And what happens at these highest grades of metamorphism, where you have very high temperatures and pressures, is that the minerals separate into distinct bands. These bands have similar minerals in them, which means you have bands of felsic minerals alternating with bands of mafic minerals, and that imparts a zebra kind of striped banding, light and dark bands, and that is a specific texture that's found in these high grade metamorphic rocks. So this rock can be identified by its banding. So you can look at the chart and discover what its name is. So that's number 65. So here we have all these metamorphic rocks. These two are non-foliated, and these are all foliated metamorphic rocks. Now, we can also look at the foliated rocks here, 62, 63, 64, and 65, as the progressive metamorphism of shale. So shale, the sedimentary rock shale, which is made up of clay minerals, when metamorphosed at low grades, will turn into 62. At higher grades of temperatures and pressures, will turn the same rock, 62 will turn into 63. At even higher grades of temperatures and pressures, 63 will turn into 64. And at the highest grade of temperatures and pressures, 64 will turn into 65. So this is the progressive metamorphism of shale. So that concludes our metamorphic rocks. So now you can fill out the chart in your metamorphic lab for sample numbers 60 to 65.